An example of a sigma bonded organometallic compound is, so there are four compounds: ferrocene, cobaltocene, ruthenocene, and Grignard reagent. This is a plain questions. So Grignard reagent you can write like RMgX. So there is a bond between the R and Mg. R is your carbon compounds. So the bond is normally a sigma complex in this position. But in case of this all three like ferrocene, cobaltocene, ruthenocene, so they are forming the pi bonded complex. So this is your pi bonded complex. So the answer is your sigma bonded organometallic compound is your Grignard reagent. So others here pi bonded complex compound. So like this is, you can see in case of ferrocene, cobaltocene, we have the structures like this. Structure is the pentagon, and with this here pi complex, and again this is the iron, and this is the bond is the pi, and again we have structures like this one. So this is your this is sandwiched between these two aromatic rings. This is your ferrocene complex is there. So our answer in this case will be your Grignard reagent. For a given reaction, delta H given, delta S given, and the reaction is spontaneous at, so they're asking temperature, at which temperature the reaction is your spontaneous. So we have to calculate this question from the thermodynamics. We know the formula delta G is equal to delta H minus T delta S. And if the reaction is spontaneous, then delta G must be your negative value. If it's negative, then this is called as a spontaneous temperature. So for delta G is negative, you should have delta H should be less than T delta S. Means the value of this would be greater than this only possible. So what temperature? If temperature is greater than delta H divided by delta S, so delta H is given 35.5 into 10 to the power 3 joule, and temperature here delta S is given 83.6 joule per joule per Kelvin. So on solving you will get here T will be your solving you will get T will be greater than 425 Kelvin. So which answer is correct? Let us see. So if you see the answer carefully, your answer is your T is 425. So answer is our 4 is our correct answer. Ionic mobility of which of the following alkali metal ions is lowest when aqueous solution of their salts are put under an electric field? Now all are belong to group 1 element. These are group 1 element. Okay. In this case, what happens? Ionic mobility is highest when the metal is largest size. So in this group element, cesium or mobility is highest. Then which is lowest? So it will, because it has a big size. That is your big size. So definitely lithium will be your smallest size, because this lithium ion is surrounded by the water molecules on both the sides. It's heavily hydrated. So due to the surrounding of this water molecules around the lithium, the size becomes very bigger, and this is called as the hydrated alkali metal. Hydrated alkali metals, and in this case the mobility of this lithium ion becomes where lowest. So answer is our 2. Which one is the most acidic compound? So if you see carefully, our nitrate ion. So nitrate ion has a strong minus I as well as minus R. So it can pull electron, withdraw electron from the your aromatic compounds, while OH, or you can say CS3, so this is the plus IR effect, or you can say plus I. So they will donate the electron density to the ring. So they cannot, in this case the acidic compound is not possible. In this case it is very less amount of acidic compound, but NO2 is having greater minus I minus R effect, minus I effect. So what will happen? This will withdraw electron from the ring, and thereby the oxygen will get the, it will pull the electron from the hydrogen. Hydrogen easily removed from this OH. And in this case, second case, If you compare with the first one, so it has 3 NO2 is there, so this is the very stronger than that of 1. So definitely 2 will be stronger than that of 1 there. And after that, next is our 4 and next is our 3. But they're asking which is the most acidic compound, so answer is 2 because it has 3 NO2 group at ortho and para positions. So this is a very strong acid in this all 4 options. So answer is 2 is the strong acid. Of the following, which is the product formed when cyclohexanone undergoes aldol condensation and followed by heating? So we have to do cyclohexanone. So cyclohexanone, this is the example of aldol condensation. This is cyclohexanone again, hexanone, and if you take the one more cyclohexanone, so this is the OH, and here we have 2 hydrogen. So definitely the base will take this hydrogen from here, so it is abstracted by this base. So this becomes your carboanion. So this becomes your carboanion, like this is your marking. This is the carboanion here. This is the hydrogen with negative charge, and here is your oxygen. So definitely this will attack on where? So this will attack on this side, on this position. So you will get the compound like this one. So you will get suppose you are writing in this format. This is the oxygen here and attacking, so this will become on here, so you will get circle like this, and here is O negative because so this is the compound attacked by. So when you attacked this on this carbon, this will undergo electromagnetic effect, so you will get this position O negative, and again this oxygen will get water, proton from the water, so this will get protonated and you will get compound. Now this is oxygen, and again this is your OH, and on heating, so if you heat it, then 1 hydrogen from here and 1 OH from, so it will undergo the condensation and you will get the compound like this one. This is the O and hydrogen, and OH is removed. Not sorry, it is here O negative because it is here. So again this is OH and OH and hydrogen removed, so you will get double bond, and this is attached by the this ring. So this is the structure is there. So if you see comparing, so out of 4 options, we have this option is correct option. The 4th is our correct answer. Mixture of chloroxylenol and terpenol act as is answer antiseptic because this 2 chloroxylenol and terpenol is the constituent of your Dettol. Antibiotic is the it will decrease the temperature, antibiotic will kill the microorganism, analgesic is the pain reliever. This is your antiseptic is your used Dettol used for our life, like a Dettol. So this is our answer. The element Z equal to 114 has been discovered recently, and we have to find their family and groups. This is given. So if you there is so many tricks to find it out, so we can use one method, like if it is 114 and if you compare 118, so what is 118? 118 is nothing but the 7p6. 187p6 is the last electron in the periodic table. So we need to find out, so if 114 given means if you subtract 118 minus 4, it will become your 7p2. If you see options, which is the 7p2, so answer is coming your 4. This is nothing but the group 14 family. So it belongs to group 14 family. Okay, so our answer 4 will be your correct answer. The correct increasing order of basic strength for the following compound is. Now this alanine and this aniline is again, you can say at para position nitro group is there. So nitro group has you can see it as a strong minus I or minus R effect. It will withdraw electron. So electron present on the nitrogen will not be act as so much strong basic. And this is the methyl. Methyl is your electron giving groups, so electron donating groups. It will donate as a plus I effect. So So it will donate electron to the ring. So in this way the ring will give electron to this nitrogen. So third is the very strong basic strength, and followed by 1 and then 2, because 2 is you're having electron withdrawing capacity. So answer will be your PC 3, 1 and 2 is our correct answer. Which of the following is depend on temperature? So mole is a pure ratio. It is not depending on temperature. Weight percentage also pure ratio. It is not depending on temperature. Molarity also pure ratio. It is also not depending upon the temperature. Molarity. So molarity is capital M. It has a volume. Molarity has a volume. So we can write here molarity is a mole by volume. So volume will expands on temperature. So volume will expands on increasing temperature. When increase the temperature, it will expand. So definitely this concentration will depend upon the temperature. While the 3 is the pure ratio, so it will not affecting the temperature. They are temperature independent. So this answer is correct. The heating of the phenyl methyl ethers with HI will produce what? So we will draw what is the phenyl methyl ether. So if you draw the diagram, this is your phenyl, and attached with the ether O, so this OCH3, and when you are reacting with the HI, so what will happen to this product? Now this has lone pair, so definitely this lone pair is in resonance with the ring, and so the I will act as a nucleophile. It will attack on, so first H will attack on this hydrogen, so it will become protonated. So after protonated due to lone pair, so this is iodine, sorry, hydrogen, so it becomes your positive charge in CH3. Now due to this protonations, what will happen? So this lone pair is in the resonance, so this bond is strong, this bond will be strong, but this bond will be weak. So this will split out and it becomes your CH3. Okay, so after splitting it becomes CH3 I, and here iodine is acting in nucleophile, so it will attack by I minus, and you will get the product CH3 iodine. So we will get two product, this plus, and next is our phenol plus methyl iodide. So which is the answer? So answer will be your the heating of phenyl methyl ether with iodine will produce this plus phenol plus CH3. So this is our correct answer. Predict the correct intermediate and product in the following reaction. This is our propylene. So propine is there, not propylene, it's propine, and propine reacting with the water. So it will be your hydration of propine. So yeah, it will undergo rearrangement. So CH3, C triple bond CH, and in this rearrangement they will follow the your Markovnikov rule. So we are just using Markovnikov rule because in presence of this mercury is a catalyst, so this pi bond is broken, and this is adding like your Markovnikov rule. So CH3 C double bond OH double bond, and here will be OH, and this will be your CH, and this is your CH2, and it will again tautomerize, undergo tautomerism. So after tautomerism, so this hydrogen migrate to this carbon, and you will get a CH3 C double bond with oxygen O and CH3. So you will get your ketone. So if you see answer, which of the following answers are correct? So first is your, we can see A is our correct answer. This someone has marked this correct answer, so this is only correct. In which pair of ions both the spaces contain SS bond? So we have this structure, let us see. So if you see here S2O7 2 negative, so we can write here sulfur oxygen, here oxygen O negative, here oxygen, here O, and this sulfur O oxygen, here O negatives, and this is oxygen. So this is not possible. If you take here S2O3, so S2O8, so S2O8 will be 2 negatives, it will be your sulfur oxygen, here will be 2 oxygen, this is sulfur oxygen, here O negatives, and here O negative, and most of this is also not possible. So let us take S4O6, so S4O7, and we can take S2O3. So 2 is there, 1 and 2. Let us take this one. So for this one, if you suppose S2O3 negative, so we can write here sulfur oxygen, and we can write here sulfur. This side sulfur is there, and oxygen negative, oxygen negative. So this is your S2O3, and next is your S2O8 2 negative. So S2O8 2 negative is there, S4O7 2 negative. So this is there, S4 2 negative. So we can write here sulfur oxygen, sulfur, this is the same, and this is sulfur is there, sulfur oxygen O negative. So we can see in this case one sulfur bond is there. Out of this option which have sulfur bonds, so if you see carefully, so which is our answer? So our answers will be, so in this case this is your 6 is there. So one is this answer and one is this one, because there is sulfur bond, the double bond can be considered as a 1. So if you see carefully option, we have this option only correct. So answer your 4 is our correct answer. HgCl2 plus I2 both when dissolved in water containing I minus ion. So this water is containing I minus ion. So what is the pair of species form? So this HgCl2, so it will react with your iodine, so it will form again Hg I2. This is a precipitate form. This is your red PPT is formed. This is a red PPT, and this is the 2I2, and again this red PPT plus 2Cl minus. So again this red PPT, it will again further react with the 2 iodine. So it will form a Hg I4, and this is a 2 negative. Okay, so this is soluble in water. So the PPT is not soluble, but this is soluble in water. But further we can see this Hg, not Hg, so here is this iodine is formed. So we have iodine also present. So again iodine, it will react with the iodide minor. Okay, so you will get here next product is your I3 minus, and I3 minus is this true product of iodine plus ions is your polyhalide ions. So this is a polyhalide ion. So we'll get answer. So which product is forming? So one is your HgI, this is soluble in water, this polyhalide is also soluble in water. So we have 1, 2. So our answer is this one correct. A 20-liter container at 400 Kelvin contains carbon dioxide at pressure 0.4 atmosphere and excess of strontium oxide. Neglect the volume solid. You have to neglect the solid volume, and the volume of the container is now decreased by moving the movable piston fitted in the container. So what is the maximum volume of the container when the pressure of carbon dioxide attains the maximum value? So this is our equation. You can see very clearly strontium carbonate is giving strontium oxide plus carbonate, and Kp is also given. So first Kp is equal to nothing but the partial pressure of this one. So this is nothing, it's 1.6 atm pressure. Now in this pressure, what is the, again if your volume is given, temperature is given, so and pressure is also given, so we can find out the here moles of carbon dioxide. So moles of carbon dioxide will be how much? It will be your Pb by RT, and pressure is given your 0.4 into 20, and RT let us write. So this is the moles of carbon dioxide. Use the formula Pv equal to N of carbon dioxide into R into T. So again temperature is same, so RT will be same. So they are asking what is the maximum volume. This is the maximum volume. So V maximum will be equal to moles of carbon dioxide RT by your considered pressure. So what is the moles of carbon dioxide? So moles of carbon dioxide already we have discussed, that is 0.4 into 20 by RT. This is the moles, and into RT. And what is the pressure? So pressure is given here 1.6. So if you solve it on solving, you will get here 5 liters. This is our answer. Let us check which is our option. So option is given here 3. Match the interhalogen compounds of column 1 with the geometry in column 2. So this is the interhalogen compound, is the geometry. So we can see the geometry XX, XX3, XX5 and XX6. So we know the halogens are forming interhalogens. So XX, if you take example like a linear compound, so XX will be your linear definitely. And if you see linear means, if you take example, you can take any example like ICl, and next you can take here XX, next is your XX dash is 3. The 3 will be your, if you take example suppose ICl3, so here examples it will be your T-shaped. Okay, next if you take here XX5 dash, so XX5 dash, suppose you take example BrF5, or you can take IF5 also. So it will be forming your square pyramidal. So structure is square pyramidal, and if you take X7, so IF7 is nothing but the pentagonal bipyramidal. Pentagonal bipyramidal. So if you see the options, so which of the options is correct? So this last option is correct. This option. Which one of the following pairs of spaces have the same bond order? So if you want to same bond order, means the spaces must be isoelectronic. So isoelectronic, we have to find out which have same number of electrons. So if you take Cn minus is 6 plus, you can say Cn minus is your how much? So 6 plus 8, so it is your 14 electrons are there. Similarly, we can see carbon also we have 14 electrons, here also 14 electrons, nitrogen 14 electrons, but for oxygen, so it is your 8 into 16 plus 17 electrons in case of oxygen. In carbon monoxide already it is 14 is there, but nitrogen it will be 8 plus 7, 15 electrons, and oxygen it is again 18 electrons, and for this one nitrogen oxygen it will be 7 plus you can say 7 your 14 electrons. So again this is also different. So only this is isoelectronic, so here bond order will be your, it will be same. So our answer 1 is correct. IUPAC name of the following compounds. So this is the aldehyde, is a ketonic, this is a double bond. So this is a principal functional group. So we carry here mark 1, 2, 3, 4, 5 and 6. 6 means it is hex, your you can see it is hexene is there, the double bonds of in 4th carbon is there. If you see carefully, this is your hexenal, and but in 3rd carbon keto is there. So 3 keto, we can say 3 keto or 2 methyl. So this option only coming at all, 3 keto 2 methyl hexene 4 enol, remaining 1 2 is wrong answer.